I'd like to show you another example of a combined gas law problem. And we know this is a combined gas law problem because we've got the gas under two sets of conditions. 400 mils of gas at 25.0 degrees, 790 millimeters of mercury. And we've got 500 mils, 30 degrees, and a new pressure. Alright, so we know that we can see two distinct sets of conditions here. There's also no mention of grams or moles, so we know it's not a PV equals nRT type problem. Alright, so let's go ahead and use our P1 V1 over T1 equals P2 V2 over T2. And I'll set this out as I did before. It doesn't really matter what you assign as being P1 V1 and T1 and P2 V2 and T2 as long as you assign what's under the same conditions together under the same set of variables. So this could be P1 V1 and T1, or it could be P2 V2 and T2. It doesn't matter which. I'm just going to put it under P1 V1 and T1. I also want to point out here that there's no mention of the gas being collected over water. Since there's no mention of that, I don't have to include anything to do with the vapor pressure of the water, and I have to subtract the vapor pressure of the water from the pressure of the total pressure of the system, as I did before, to get the pressure of the gas. So I can just use the pressure as it stands here because there's no mention of it being collected over water. So again, the importance of knowing your units for pressure and volume are going to be important here. If you know that millimeters of mercury is a pressure measurement and milliliters is a volume, it makes it easy to pick out what's going to be P1 and what's going to be V1, for example. And temperature one here is going to be 25.0 degrees Celsius, but we know that that's going to end up being converted into Kelvin, and that's going to be 298 K. And pressure 2 is what we're looking for, so that gets the question mark. Volume 2 is 500 mils. And the temperature 2 is 30 degrees, 30.0 degrees. And we're going to add 298 to that. And that'll give us 303. Sorry, we're going to add 273 to that, sorry. Take that back. There we go, it's better. 273. And that's going to be 303 Kelvin. Alright, so now what I'll do is I will isolate. I need to isolate P2, so we know that V2 will end up down here. We know that T2 will end up on top. And what I'm doing there is dividing both sides by V2 and multiplying both sides by T2. So what that becomes is P1 V1 T2 over T1 V2, and that's what P2 is going to equal. Now I can just plug in the values. I've got 790 millimeters of mercury. I've got the volume one, which is 400 milliliters. Times temperature 2, 303 Kelvin. Temperature 1, 298 K. And volume 2, which is 500 mils. And the final answer there comes out to 643 millimeters of mercury.